All right, this is Math 1, Unit 1B for the year 1718. 1.6 is the lesson here on solving proportions. It says to solve proportions using the multiplication property of equality. So what we're looking at here is, actually, okay, well, let me show you how to work this out. One of the things I'm looking at here is I can think about it because it's proportion. I can ask myself to go from 4 to 12. What multiplication factor will it take to move from 4 to 12? So in my mind, I know that 4 times 3 equals 12. As a result, I want to ask myself, okay, if I do 3 times 3, that will give me the value of A. So in this case here, A is going to equal 9. Okay, looking for how I move it across there. If I look over here, for example, to go from 3 to 21 as a multiplication property, that's going to be times 7. So if I do that times 7 to my top value, 1 times 7 is 7 for number 2. Alright, when you move to this side here, it doesn't quite work out as nicely. You can't see a connection between 5 to 3 and that to that. So in this case, the way I tend to solve this here is I will do cross products property. I'm not sure what the multiplication property is right now, so I'm not going to worry about that. This is kind of an easy way of doing it. So I'm going to cross multiply, and I do 5 times 2 is 10. And that's going to equal this part, which is 3x. Now I'm back to an algebra problem, and I'll divide both sides by 3. And this reduces down to x, and I have 10 divided by 3. 10 divided by 3 in my calculator ends up being 3.33, and it goes on forever, equals x there. And number 4, when I'm looking at here, when I see, okay, I'm going to go this direction, to go 8 to 24, that's a multiplication factor of 3, 8 times 3. And so over here, 3 times 3 is 9. And that's kind of your idea of what you're looking at there. Okay, again over here, same idea. We'd look and see what's happening from one to the other. And I could reduce, I could cross multiply. My method is probably cross multiply, which is more what we have down here. It just tends to work a little faster for me. So let's take a look at number 7. Number 7, I cross multiply. 18 times 2 is 36. And that's going to equal this part, which is 5k. Now to get the k by itself, I'll divide both sides by 5. And I have 36 divided by 5, which equals 7.2 is what the value of k would be for the top part of that. Let's look at number 10. And again, cross multiply. 4 times 4 is 16. And this is equal to d times negative 1. I could write negative 1d if I really wanted to, or just negative d. I don't want to leave this as a negative number, or a negative value here, so I'm going to divide both sides by negative 1. That will make the negative 1s go away. 16 divided by negative 1 is negative 16, and that's going to equal d for number 10. Number 11, if I cross multiply, I have 13 times 5. And I actually have a negative times a negative, so I end up with a positive. So this becomes positive 65 equals 15k. I'll divide both sides by 15, divide by 15, and I find out that k is equal to 4.33, and it tends to repeat, equals k, using cross multiplication there. When you come down to the next ones, these are some ratio or proportion problems, as well. So we have to look at what's happening here in the story problem itself to figure out our solution. Let's look at number 14. It says Jennifer is ordering cake for her wedding reception. If one cake will feed 18 people, right? So that's one cake will feed 18 people. How many cakes does she need to order for 15 people? So this is X cakes for 150 people, is what we're looking at now. So we're saying I want to go from 18 to 150 and cake to cake. In this case, I'm going to cross multiply and do 150 equals 18x. So I'll do 150 then. I'm going to divide both sides by 18 to get the x by itself. So 150 divided by 18 is going to equal 8.33 for my value of x. Now when you look at this one here, I can't give someone part of a cake, right? So how many cakes does she need? Because it's more than 8, I would actually say she realistically needs 9 cakes in order to take care of that. You don't want to have a little bit of, some people don't get a whole thing, so we would actually round that up to 9 for our solution for number 14. Let's take a look at the back side. On the back side of this, the same idea. Let's take a look at solving some proportions here. Now in this case, we have some variables that are a little mixed in with what we already have going on. So to make this work, I'm going to focus here real quick. A little better, about the same. I'll cross multiply, and I have 5 times 2 is 10, and that's going to equal 4 times j plus 3. I could write it out like this, j plus 3, and then I could distribute if I chose to, or I could divide by 4 first of all. I'm going to distribute first of all. So I'm going to say 10 equals 4 times j is 4j, and then 4 times 3 is 12. Now I'm going to subtract both sides by 12 from both sides to get that to go away. So now I have a negative 2 equals 4j. Divide both sides by 4. Negative 2 divided by 4 ends up being negative 1/2 when I reduce that, and that's the value of j for number 16. Okay, let's look at number 19. Same idea. I have here 3 times 15b. So this becomes 3 times 15 minus b equals 6 times negative 2 is negative 12. Again, I could distribute first or I could divide first. This time, let's divide first. I'm going to divide both sides by 3. Divide both sides by 3. That makes the 3 go away. And on this side, I'm left with 15 minus b equals negative 12 divided by 3 is negative 4. Now the reason I divided this time but not last time is I knew that 3 was a factor of 12, so I get a nice even number. Whereas before, if I had divided 10 by 4, I would have ended up with something a little bit funky, so I didn't want to mess with it. And that's why I chose to do it that way this time. Now I can go ahead and I can subtract 15 from both sides. So that's going to go away. The signs are the same, so I find the sum and keep the sign the same. And I have negative b equals negative 19. I don't want to keep my variables negative, so if I multiply both sides by a negative 1, a negative times a negative is a positive, and a negative times a negative is a positive, so I end up with b equals 19 for number 19. Okay? Let's look at 21. On the football team, 2 out of every 7 players are seniors. So 2 out of every 7 players are seniors. Okay? These are my seniors, these are my players. So 2 are seniors out of every 7 players. If the team has 84 players, make sure we're matching player to player, how many of them are not seniors? So to solve this here, I could solve it like this, but if I solve this, this is going to tell me how many seniors I have. Okay? Nothing wrong with doing that. That's okay. Or I could set up this way. If 2 out of 7 are seniors, how many of this initial ratio or portion are not seniors? Well, what's left? 5 of the 7 are actually not seniors. So I could set it up like this. 5 over 7 equals x over 84. I could solve either one of these and get a solution. If I do this solution, then I have to do some subtraction at the end because that will tell me how many are seniors. This will tell me how many are not seniors. So there's an extra step there. I'm going to go ahead and go this way. So I'm going to multiply 84 times 5, 84 times 5, and I get 420 equals 7x. To get the x by itself, I divide both sides by 7. So 420 divided by 7 happens to be 60. That's how many players are not seniors. Okay? So over here, if I did that, I would do 84 times 2, which gets you 168 equals 7x. I divide that by 7, and that gives me 24. But that's how many seniors there would be. So from this problem here, I wouldn't be done yet. I would have to go to the next step, which is the number of players minus the seniors to give me 60. And that would be your answer there. So an extra step. You can either do subtraction at the end with a big problem, or like I did here, I did my subtraction early to get a different proportion. get the 5 going on there. All right, so hopefully that's a little bit of homework help for you. Helps get you going the right way on what you want to do there. Oh, let's do one more. I'm thinking about it. Let's go ahead and do number 22 because I see variables on both sides. Okay. All right. Sorry. Let's look at that. So I have 5n, and on this side I have equals to -1 times n minus 12. In this case here, I'll distribute the -1. So that's going to be -1n becomes -n. -1 times -12 is a positive 12. Okay. Now in this case, I need to combine my like terms. Oh yeah. So let's add n to both sides. So the n's go away. This is 5n plus a 1n, which is a 6n equals 12. I divide both sides by 6, and n is going to equal 12 divided by 6 is 2. So the only difference here is that once I do my cross multiplication, I have to combine some like terms. You see over here on this one here with the v's and the v's, you do the same thing on that one. So make sure you just got the idea. All right, hope that helps. Good luck on the rest of the problems.